8.4. Ha! We win. All right. It's not up there yet. Okay, but I'll keep talking. 8.4. What we're using are these like properties of logs, and they just kind of do everything for you. So, for example, the product property, it goes from multiplying m and n here. You can take that and split it into two logs that are being added together. All right, so we go from multiplication to addition. So I'm going to write that down. That this one is from multiplication to addition. The next one is called the quotient property, and you see that there's a quotient here that we're taking the log base b of that. We can go from the quotient to subtraction. So that one is division to subtraction. The next one is called the power property. This one, you have an exponent within the log. So we're taking log base b of m to the p. What we can do is take that exponent and push it all the way to the front, and it becomes a coefficient. So this one is exponent to coefficient. The handwriting is subpar today. And getting worse. All right. The last one, we've actually already used this. We used this in the beginning of 8.3. So we have log base b of m equals log base b of n. So if m equal if the whole thing's equal, then m must equal n, right? Okay, so you're just saying we're taking the same log base b of these two numbers, so those two numbers have to be equal. All right, so we use these to manipulate logs to make them look like what's easiest for us. In the first examples, here the problem has already been done. They have rewritten it. We're just identifying which properties they used. So for A, how did they get from here to here? What do you notice? It goes from subtraction and then ended up with 2. So what did they use? You were right the first time. The quotient, right? Quotient. Oh, that's you that said it. Okay. Quotient. Because, so what they did was log base 2 of 8 divided by 4. And that 8 divided by 4 reduced to 2. So that was quotient property. Very good. All right. What about the next one? I think they used more than one on this. So what do you notice?
Oh, the power one.
The power one, because our exponent ended up in front, and what else? Product, because it went from multiplication to addition. So power and product.
Why didn't we write anything on the end of the
Because I don't know. There wasn't really a transition to write. Sorry. All right. We okay with it? Identifying what they used? Yes? Okay. Now we're going to simplify them ourselves. So what can we do with this? Let's see, we have log. Are the bases the same? Yeah. Yes. Okay, so that allows us to use those properties. So what can we do with the 20 and the 4? Divide them. So we'll write log base 3. Which one goes on top? 20 divided by 4. So what does this equal? Log base 3 of 5. That would be our answer.
What if they weren't the same
Base. If they weren't the same base, then you can't use those properties.
Why can't you just subtract?
So always just put like not after.
That's not how it works. because remember that this is all exponent stuff. Logs come from exponents, so it's like confusing. Yeah, just trust it. All right, what can we do with the next one?
Bring the 3 over to the table, Jake.
So the 3 is gonna come over here. Is that what you're saying?
Yeah.
What property is that? Power. So we have log base 2 of x cubed plus log base 2 of y. Now what? They're being added and they have the same base. So what can we do to combine them into one log? Multiplication. So it would be x cubed y. That comes from the product. So, hey, that's the one that was actually kind of up above there. It just has a different base. So we use the power first to move that 3 into the log. So now it's an exponent, and then we use product to multiply those 2 together to make one log. We okay?
Wait, so you did what for the second one?
In example 3, we're doing the opposite. We're starting with a single logarithm, and we're going to expand it as much as we can. So these are already being divided. So what can we do? Okay, so we're going back to look at this because the question was asked, does it matter which one you do first? Like, could we have combined them by the product rule first? And the answer is no, because that 3 in front doesn't make them the same. We had to put the 3 in there first and then multiply them together. So that was a very good question. So you have to deal with that coefficient and get rid of it first. No. Okay, so Whitney, what do I do with this one?
You
How do I break it
split
apart?
up into 2 and say log 5x plus log 5y.
Let's see. What's the sign that goes in between them?
Well, I don't know.
It's quotient, so look up above. To go from a quotient, what sign should we have? Minus. All right, are there any like exponents that need to be moved or anything? No, so that's our answer. Next one, what do we do first?
Remove the powers.
We got to split it up first. As we're breaking it apart, you split it first and exponents are last. Yes, Chris is correct. We do log 7a cubed plus, because it was multiplication, log 7b to the 4th. It's very important that the base goes with everything. Now, what do I do?
Remove 3 in front of 3 log 7a plus in the 4 and the 4 2.
Very, very good. Log 3 log base 7 of a plus 4 log base 7 of b. Very, very good. Good job.
That's the end. Are we done?
We still got to do the back.
Oh.
I didn't. We're on the next page.